Our issue that we're going to address really has to do with the way that the real world systems work. Real world systems have a lot of log information. Programmers will output debug information, errors, and various information about the programs that they're writing. And this happens at various levels, right? The hardware will put out logs, the operating system will put out logs, applications put out logs. So we've got this rich set of information that isn't really used very much. It's used for immediate debugging, but it'd be more useful if we could determine, is this flow of information somehow different? Does it happen? What's happening right now, is that unusual? Our project really is about finding that set of logs, taking some set of logs and determining, is this particular set in this set at a certain time, is there a set of log entries that are unusual, that are problematic?
We monitor about 1,500 network devices and switches, hundreds of Windows servers, and at least 1,000 or more Linux boxes. And each of them are generating log files that we then capture on a periodic basis and pull to a central location. So I'm not sure what the number of those files are, but there's thousands of devices on campus being monitored. So we're not getting as much out of it as we'd like out of the system. Like I said, we're looking for particular errors for PCI, and so we do get that and are able to remain compliant with those requirements. But we gather a lot of data. We gather from 3 different servers. One collects Linux, one collects Windows data, one collects all the logs from the network devices. And we really aren't getting the value out of that we could.
Our first goal for the project was really to be able to get something working that could analyze logs and to at least be able to help the user. And that's what we planned out to tackle first.
Logstash is unique because it's able to be able to ingest logs. And logs are in many different formats. You have syslogs, you have many various types of formats out there. And to be able to get them into a unified format is really what you need before you can even run any kind of analysis on it. So Logstash puts it into a unified format ready to be analyzed. And it's one of the key elements, one of the key parts of software that we're using in this project. Once we have the logs into a unified format, we want to be able to put them into a database engine. And the database engine that we're using for this project is Elasticsearch. Elasticsearch is really powerful because it's a real-time querying engine, meaning that the logs will be stored there in a unified format, and queries can be run on them to be able to figure out if there's anything similar between the logs, if there's any anomalies out there. And it really just gives a base so that the user or any other kind of machine can be able to try to figure out stuff from the logs. And once we have that, we have Kibana, which is a front-end face to that database, to essentially allow the user to be able to go through graphs, to be able to go through the data that is collected, and to be able to try and make sense out of it. So this system is something that has been implemented and it works well. However, something that's missing is a machine that is a statistical analysis machine, something that can read the data that's in Elasticsearch and to be able to make sense of it, to be able to cut down on the human time and to be able to get the computer to do more of the analysis itself.
One of the major hurdles that our project had to overcome was defining what an anomaly is. It's really difficult to say what an anomaly is because it's different for every system. For one system, it may be completely normal to create thousands of logs per minute for just one application, if it's a Tuesday at 5 p.m. However, that same system may not create nearly as many logs if it's 3 a.m., just due to the application that's being run on it. So we had to define some sort of statistical model that would be able to take in all of these many variable factors and deal with them. The multinomial goodness of fit test is able to take in many different variables and calculate them all together and see if what it's found is outside the normal range. If it is outside the normal range, then it could be considered an anomaly, and we can throw some sort of alert from there. One of the other useful parts of it is that unlike some other historical models that have been used to analyze logs, it's able to learn and recognize new patterns over time as they come. If you change a server and the logs begin to seem different because the application is different, then you will notice that the multinomial goodness of fit test will adapt and change over time so that it is able to recognize what the new valid range is.
Morgoth is a pluggable framework for being able to take these statistical methods for analyzing metrics and determining whether there's an anomaly within a given set of metrics. Morgoth was initially built using the multinomial goodness of fit test for ingesting metrics and performing anomaly detection on them. And so inside of Morgoth, for this plugin, was developed this concept of windowing data, such that you could analyze windows of data 30 minutes, 1 minute, 5 minutes, based on the number of metrics per minute that you're getting. And when I say it's pluggable, we decided that the statistical methods that we were using may be the best choice, but that for different sets of data, different methods might be more applicable. And so because it's pluggable, you can develop your own algorithm by taking whatever statistical methods you want and just dropping it in and configuring Morgoth to be able to use that.
Multinomial goodness of fit test looks at the shape of the probability distributions. As it does that, it remembers how many times it has seen that shape for a given window. It's configurable, and you can set how many times that shape is acceptable to be seen before it is considered to be normal behavior. So Morgoth has to be fed a good set of training data so it knows what to expect from your data, what it should look like. And so when it sees these different probability distributions, it knows what to detect as an anomaly.
Morgoth was initially built and designed based off of accepting simple metrics from sources such as graphite to analyze CPU memory usage, but it can easily be adapted to pull metrics from Elasticsearch. Elasticsearch has a very extensive REST API so that we could request the metrics that we want. Morgoth tracks the minimum and maximum values of data that is sent to it. And so as new minimums and new maximums come into the data, it keeps track of that and kind of resets itself so that it can perform its analysis based on the new range of data that it's currently seeing.
So this framework, Morgoth, built on top of Logstash and Elasticsearch, in the future can be developed to be able to predict anomalies, where now it can detect these anomalies using another statistical method on top of what's currently being used. It can detect when anomalies are going to happen and be able to predict future anomalies.
So the solution you've shown today would help because it does a better job of parsing what's actually in the logs. You can go beyond looking at just the quantity of syslog errors or warnings and get some insight to what's actually going on inside those messages and be able to make better decisions about what to do to keep the systems up and running and keep the environment more resilient.